Alright, today we're going to be going over lesson 1.14, Transformations, Part 2. The objectives in this lesson is to identify a rotation or translation that could produce a given image from a pre-image, to describe properties of translations, and to describe properties of rotations. Some of the new terms that aren't so new that you'll be talking about in this lesson are isometry, reflection, rotation, and translation. And I just wanted to remind you of our different types of transformations. We've got the reflection, which is a flipping. We got the translation, which is a sliding. We've got rotation, which is turning, and a dilation that results in an image that is smaller or larger. And remember, with our isometric transformation, we always preserve the size and shape of a pre-image. So the only transformations that are isometric are reflection, translation, and rotation. And just an FYI, that's a question on your test. So let's talk about translations. Remember, that's the sliding of a figure in a straight path without rotation or reflection. And hold on just a moment, I forgot to do a little thing to this slide. Okay. Look, I've added the square because the square was very important for you understanding what was going on. Remember, translation is the sliding of a figure in a straight path without rotation or reflection. So what that means is you're taking this square and you're just moving it to another place. That's all a translation is. Okay? Even if I had it over here and I said, okay, I'm going to move it up like that, that's still a translation. You just don't want to rotate it or reflect it, which with the square it's pretty hard to tell if you're rotating or reflecting, but with other shapes it's going to be really easy to tell what kind of transformations taking place. Now with the rotation, you know, I kind of just took a picture of what you see in the LMS lesson, because rotations are just pretty tricky, guys, to explain. And what you're going to notice in your lesson is how you see this wheel and you've got this reflector that's in the center, and over here it's obvious that it's rotated, but it's rotated about the center. Now you come over here and you look at this one. Well, they put this reflector on the edge close to the tire, and you can tell here that it's rotated like that. Now what I want to show you is I had a question by another student, and of course now it's not being readily available because that's the way they roll. Let me pull it up. It's opening. I want to show you a picture, and I'm going to put it right on top of this one. Well, I pushed copy, and it's not wanting to copy. I've never had this happen before. Oh well, I guess I can't show it to you. Bummer. I'm going to pause the recording for just a minute and see if I can get it to come up that way. There we go. I got it. This is great. Okay, now I can help you with this rotation. Alright, if you look right here, it says trapezoid PQRS was rotated 60 degrees around a point. Which point could have been the center of its rotation? Well, C looks really pretty because it's right there in the middle, but if you look at this yellow circle and compare it to this trapezoid, it is all over the place. Okay, when I tried to put this circle on here, I lined it up with point S, but I would have to completely move the circle to get it to line up with point R. I would have to move the circle. Well, moving the circle isn't really a good example. And I told the student I was helping this problem, this is so much easier to see when you're graphing on a coordinate plane versus just throwing it out there. But if you look at this red circle, look how it lines up with point S. Okay, instead of saying moving the circle, let's say make the circle bigger. And of course I can't make it bigger, but on this, because I just pasted this picture, but let's just say for instance I took the circle and I enlarged it. Okay, I don't move it, I just enlarge it. So when I enlarge it, point B stays the center. Okay, so if I enlarge it, it's going to line up with point R here, and it will also line up with point R here. Now then, if I enlarged the yellow circle to go to point R, it would be going a further distance away from this point R. Okay, they wouldn't be, both points wouldn't be on the circle, and that's what you want. If I was to enlarge this circle to go to point Q, once I got there, if I looked, this point Q would also be on the red circle. It's not the same with the yellow circle. Okay, so I hope that helps you understand just a little bit more about how the rotations work and what they mean when they want you to figure out what the center of rotation would be. And y'all be sure to ask me questions if you still don't understand that. Okay, let's look at some examples. It says Mickey is straightening up some things in her living room. Describe the transformation needed for each fix. Now, there wasn't a lot of examples to use for you, so I just picked out the one that I could use because most of it is actually you doing sketches and drawings. Okay, a clock is in the right spot, but it's upside down. So if you think about the clock being upside down, all you would have to do, it's in the same place, all you would have to do is turn it. Okay, so remember when we say we're going to turn it, that makes it a rotation. Now Mickey's couch has slid all the way to the opposite wall. Not sure how that happened, okay, but it has slid all the way to the opposite wall. So if I'm going to slide it back to the original wall, did you hear that key word I used? I'm going to slide it back to that original wall. That makes it a translation. Okay, let's see what the next one is. A small rug is turned over on the wrong side. Well, here's your key word, turned over. Well, it's really not your key. It is, but it's not. Okay, a small rug has been flipped over on the wrong side. There, flipped would be your key word. And remember, when you're flipping something, it's going to be a reflection, just like it's looking in the mirror. Of the described transformations, which ones are isometric and why? Well, you got to remember, you go back to that one slide, it said the only transformation that is not isometric is a dilation. If we look at A, B, and C here, none of those was a dilation. Okay? All are isometric because they did not change size or shape. Okay? Remember, that's the key to the isometry, is that whenever they move, they don't change their size and they don't change their shape. Now, to summarize what we've talked about, a rotation moves all the points in a pre-image in a circular path around a set point called the center of rotation. And a translation moves all the points in the pre-image a certain distance in a certain direction. Okay, and I showed you some pretty good examples of both of those. And, oh, I didn't do what you need to do. Okay, what I want you to do is to look at the end of your study guide, and it tells you what problems you need to be working in the problem set. This is lesson 1.14, so you need to be going through and reading that LMS lesson when you get finished with this video. You need to work the assigned problems in the student guide, and be sure to complete the student guide as you go through the LMS lesson. And then be sure to ask me any questions before you take the quiz. And I just want to thank y'all for listening, and we'll talk to you later.